talk about our objective. Before we get into it, I want you to pause and think and show me teamwork with your partner right from the beginning. Think about this question for 2 minutes. How many eyes do we have in this classroom right now? Include me and Miss Ollie. How many eyes do we all have in this classroom right now? 2 minutes with your partner. How many eyes do we have in this classroom right now with your partner?
1, 2, 3, 4, 5,
Write it down once you got it. Write it down once you got it. Sponge position in 5, 4, 3, 2, and 1. Thank you, Cambria. This section looks awesome. Tatiana, you writing down your answer? Okay. Very good. Now, raise your hand if you feel like you got an answer that you think is just so right, that is absolutely the right answer, that is how many eyes we have in this classroom, including me and Miss Ollie. Jamaria?
48.
48? Raise your hand if you got something different. Raise your hand if you got something different. Shakayla?
46.
46. Okay. Raise your hand if you got something different from 48 or 46. Leah? 44. Okay, these are 3 different answers, and we're going to step back and figure out, hands down please, we're going to step back and figure out what the right answer is. But first I want to hear from the people whether or not you got 48, 46, 44. How did you do this? Raise your hand if you want to tell me and this class how you solved this problem. How did you do this problem? Sit down, Mark. How did you do this problem, Shakish?
So first, you count everybody in your classroom and how many people that you had in your classroom. You added up and this show.
Excuse me, Sierra. So you counted how many people were in the classroom, and then what did you do?
And then I added up, and then I put
What was your answer?
23.
Okay, so you added the people and then added what? You counted the people, which was 23. What could she have done after she counted the people? That was multiplied by 2. What else could she have done to get the answer?
I did way by people. And most of the time I think I had 2 eyes.
Okay, so you could count by 2s like 2, 4, 6, 8, 10 because we each have 2 eyes. You can multiply by 2 because we each have 2 eyes. Let's count how many people we have together along with me, right? Ooh.
1, 2, 3.
Shakish, along with me. 1, 2, 3,
4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 23. She already got this out. No. Sponge position in 5, 4, 3, 2, 1. Let me double check. 4, 6, 8, 22, 23. So, 23, if I were to count by 2s, I would go 2, 4, 6, 8, 10, 12, 23 times. Let's do 23 times 2. Who can help me? Raise your hand. Who can help me? Raise your hand. Jonathan? Jonathan?
3 times 2 is 6. I carried my wins 2.
Is there one to carry? No? Let's keep going. 4. Go ahead, Jonathan. 3 times 2 is 6. What's next?
2 down.
What do you do next? You did 3 times 2. What do you need to do next? We did our 1s. Now we need to do our
2.
2.
what place value?
2.
10. So 2 times 2?
4.
4. Remember, we move up our 1s, then across to our 10. 46. Okay? But we did it in the right way. Whether we counted a too high or too low number of people, it seems like we all found an answer that was reasonable considering what we did. Now, how does this relate? How does this relate to what we're doing today? Today we are going to be talking about these rules in math that we call functions. Okay? That we call functions. A function is basically a synonym for rule that doesn't change. Now, when we think about what we just did, what never changed about that process? What was our rule?
Count by 2.
Why did we count by 2s?
Because we have 2
Because we have 2 eyes. The 2 eyes is our rule here, right? We counted by 2s. That didn't change. I could have had 22, 23, or 24 people in my classes. That would change. But the fact that each person had 2 eyes doesn't change. That was a rule. That was in math what we would call a function. So today we're going to talk about these functions. Take out your notebooks and pencils if they're not out already. They should be. They should be. Go ahead. A function is a rule that relates an input to an output, and we will discuss what exactly that means in a moment. For now, just take these notes in your notebook quietly. Shakish. Pencils on the board. There's a pencil in the corner. What does that mean?
Virgin.
Next time, Shakish, just be careful about calling out, okay? I feel like if you just control that volume, you'll do fine. Thank you, Caleb. Let me know you're done. Thank you, Dustin. Yeah, can you also include that there's 3 parts of a function? Include that bit in your notes. Thank you. Look at Desi sitting in sponge when she's done. Thank you. We'll give ourselves 1 minute. Thank you. Marcavius. Marcavius. Sanders. Sponge when you're done. Thank you, honey. Thank you. Thank you. Thank you. Okay, so just like we did that example with the eyes today where our function where each person has 2 eyes, we're going to be looking at some more cases where we're dealing with rules, with patterns, all right? Can I please have Destiny Austin read the definition of a function?
Function rule that relates an input to an output.
And Destiny Brown, can you relate the 3, or can you read the 3 parts of a function?
There are always 3 main parts of a function. Number 1, the input. Number 2, the relationship. And the output.
Now, to kind of talk about when Sierra gets back, to talk about what that means in relation to what we just did with our eyes. If we're going to look at the 3 main parts of a function, Sierra, she's trying to get out to use the restroom. Do you mind moving your desk up to me?
Thank you. Thank you.
In the hallway before you come back, can you please tuck in your shirt?
Yeah.
If we're thinking about the problem we just did, Tybon. If we're thinking about the problem we just did, Tybon. In respect to those 3 parts of the function, we have our input, the relationship, and the output. The input is what we start with, right? That starting thing. In our example, we started with the amount of students in our class, right? All of you said, the first thing I did was I counted how many of us were in this room. Because in order for us to know how many eyes we had, we needed to know how many of us there were, right? That's our input. Then what we did is we said every person has 2 eyes, okay? That's what doesn't change.
We would have got or did it.
What if I said there were only 3 students? Raise your hand so you can explain to me. Only 3 students. How many eyes I would get and how you got that. Kayla. And how you got that.
Because 3 times 2 equals 6.
And why did you do times 2?
Because we got 2 eyes.
And that doesn't change, right? What if I said there were 50 people in the classroom and I wanted to see how many eyes they all had? What would you do? Here, Gabrielle.
I will multiply 50 times 2, and I didn't have 100 because each person has 2 eyes.
And that's our function, right? So, most of us don't have problems looking like this on our test, right? Does anyone remember from last year how we organized inputs and outputs? What did we put our inputs and outputs in last year? Tasia. Not the numbers, like how do we organize our inputs and outputs? Do you remember? It's okay. Do you want to phone a friend? Charts or what else can we call that? Function tables. Good memory. Function tables. A function table is a table that orders that information for us. Marcavius. A function table is a table that orders that information for us. And I need this in our notes because we love our vocabulary on our quizzes on Friday. Let's go. When you see functions on your test, it's going to be in a table form more often than not. Tatiana Hunt, you drop your pencil? Hey, Shakish, how would you ask if you can sharpen your pencil instead of asking Miss Ollie to do it? I think you can do it yourself. I think there's another way you can do it. Go ahead, Shakish. Thank you, John. We have someone out. I'll let you know when, okay? Thank you, Destiny. Thank you. You 4. That's in 10. Jacayla, I'll let you know when, okay? You were next one, David. Thank you, Jonathan. Doing a good job today, Jonathan. Engaged. Thank you. Good job, Tyvon. Now, whenever you see a table that organizes inputs and outputs from now on, what are we going to call it? A function table. We're not going to call it table X, Y, blah. We're going to call it a function table because we know this word now. Okay, last year in the 4th grade, you might have called it just an input-output table, right? An input-output table. Thank you, Cambria. Thank you. But this year, you're going to hear it in both ways. You might read a problem where it's called an input-output table. You might read a problem where it's called a function table. So we need to be able to know both as well, okay? Now, if we were going to take the data that we just collected about our class, how about you borrow Kayla since you walked in a little late, okay? About our class and eyes. What would I put in my number of students column? 23, and what would I put in my number of eyes? 46. So let me quickly add this in. 23, 46. We're going to create a function table that'll be full by the end of the day. Now, on the MCT2 test and in the real world, more in the real world than ever, you're more likely to find tables that look like this because it's about things that we know, that we can see, that we can analyze. But sometimes you're going to get tables that are just X and Y, okay? Inputs, outputs, that aren't really having to do with anything besides the rule they give you, okay? We're going to practice really quickly how to put the inputs in when it looks like this. What is our rule that we notice here? x equals times 2, right? X times 2 equals what? Do we think we have enough information to fill this table? Yes. For the next minute and a half, fill this table with your partner. For the next minute and a half, fill this table with your partner. Can you go to that? Yeah. Right now, what are we doing? The table. You catch him, Arcadia, something, please. Thank you. Let's go. Don't feel like you have to be silent, people. You have a minute and a half to talk with your partners through this.
Like 14 and 2
Do I add 2 with my rule? Times 2. So I put 14 times 2. What would I put in the y column? I think it would be helpful to draw the table for your notes. Yeah. Yeah. We're doing the x and y one, though, Tasha. The number of students and I will have tomorrow. All right. How do I fill in that box? Approximately 14. How do you know that? Okay, the input, and how do I get to the output? How did you know you're 28? Smart girl, how did you know that? So what's our rule here? What's our function? Multiply by what? So whenever I'm putting something in the table to get an output, I need to do what? Then why are you sitting here with your pen in your hand and not on that paper? Let me write this on the board. You try your best to get started. If you have questions, Jamario might be a good person to ask, okay? Sponge position in 5, 4, 3, 2, and 1. Thank you to Kibby and Tatiana. Thank you to Maya and Christiana. Sierra, let's sit up. They're a little too loud for me to leave the door open. Talk to me. What would I put in this box and why do you know? What would I put in this output box and why do you know, Maya?
because 14 times 2 is 28.
And why did you do times 2?
Because the rule is that you have to multiply.
So what's a synonym for rule that we just learned today? Function. Good. How about this box? 66. What's the output for 66 as our input?
122.
Hands, please. Hands, please. Marquez. 132. Be careful to add, Sierra, what you carry. Okay? And this box. 3,557. Jamar?
7,114.
114.
114.
Okay, if you say and, what am I going to think?
This is
All right. What about 25? Hands, please. 25 with your hands in the air. Juwan. 50. 367. Hands, please. 367. Daphne Brown again.
367 times 2 equals 734.
Now, what if I gave you this? What if I gave you 8 as an output? What if I gave you 8 as an output? What if I gave you 8 as an output? What would my input be? If I gave you 8 as an output. Gabrielle? How do you know that?
Because 4 times 2.
4 times 2 is 8. If you get the rule, you can figure out the inverse operation and work backwards. So 8 divided by 2 is 4. 4 times 2 is 8. Now, let's think about something we've seen before we do some partner work. We've seen this last week, right? Raise your hand if this looks familiar. Chart on symmetry, okay? Chart on symmetry in regular shapes. If I have a regular hexagon, how many lines of symmetry do I have? 6. If I have a regular nonagon, how many lines of symmetry do I have? 9. So remember this chart that we saw here? Number of sides, numbers of lines of symmetry. This is a table that organized the information for us well, but when I was looking at it, I realized this could also be a function table too. What is the rule that I see between these numbers?
Equal.
They're equal. How can I show that they're equal with either multiplication or addition?
You got by saying 3 and blank 3.
3 blank 3. What can I fill in that blank with to get 3?
Multiplication.
Times what?
1.
Times 1 or plus
Plus
0. Thank you. So I could do a function of times 1 or plus 0. Okay? You start noticing this stuff the more you look at it. Go ahead. Try this problem with your partner. 2 minutes. This is an FCT2 problem that you may see on your test. Before we do our partner work, let's make sure we got it. Write it down. Once you get it, justify. Once you get it, write it down and justify. Okay?
Yes, I did.
This is the bottom. And throw it down. Clear one. Why? How did you know the time when you looked?
Multiplied.
Okay, the input and the output. How do I get the input and output?
I did.
I'm going to multiply. What are ways that I can do the multiply? How can I get the multiply? Plus 4, what else do I do?
Write these two.
1 times 5. So let's look at 1 plus 4 equals 5. If that's my rule, it should work for all those, right? 3 plus 4 is that equal to 52. No, it doesn't work. Is that a rule? Is that a function? What else did you say for this? You said plus 4 and equal to 8 times 5. Find position in 5, 4, 3, Tyvon, 2, Shakayla, and 1. Justify, please. Justify, please. Christiana.
G, because if I multiply 5 times 1 is 5. 5 times 3 is 15. And 2 times 5 is 25. 5 times 7 is 13.
So how did you know to times 5 in the first place?
Because it's just the opposite. And it has
Eyes. Eyes.
it has 15, 25 again.
That's a good observation, but I think that there's another way we could have found that we were looking at times 5. That doesn't necessarily have to do with the fact that these are all odds. I mean, they are all multiples of 5. That is a good observation, so I would maybe look at these two because of that. I like that. How did I know to multiply and not divide?
Because if you look at the facts, you can multiply 1 times 5, get 5. Then you can multiply 3 times 5, get 15. Then you multiply 5 times 5, equals 25. Then you multiply 7 times 5, equals 30.
So I can tell that's what you were thinking from when you were saying this. Now, Cambria, when I was talking to her and Shakayla, she said, oh, it's plus 4. Why would she think it's plus 4? Why is that a good mistake to make? Why do we think that maybe that's, like, not the worst mistake to make, Gabrielle?
Because he looked at the first, she thought 4 plus 1 equals 5.
Right? But when we try it, does it work? No. So then we have to step back and try again. All right, with your partners, for the rest of the time together, we are going to be looking at some more real-world examples of functions. Excuse me. We're going to be looking at some more real-world examples of functions and some MCT2 problems. What you don't finish